Hello. Hello friends, welcome to another video of Zeta Axis, and today we are going to start part 1 of GC Leong. So remember, the GC Leong book has been divided into two parts. In the first part, they are discussing about the earth, origin of earth and the landforms and how different landforms are shaped by glaciers, water and other sources. In the second part, it is about climatology. It is about different types of climate. So we have already covered the second part, and today we are going to start the first part, in which there will be 12 chapters. So for each chapter there will be almost one video, and this is our first chapter of GC Leong, that is the earth and the universe. In this we will basically talk about some basic points about the earth and the universe. So the first thing that we know is the solar system. But what is the solar system? Solar system is generally considered the planets and sets of other bodies which are surrounding our sun or which are very close to the sun. So our solar system is located in Milky Way galaxy. Remember, a galaxy is a system which has billions of stars. So out of those billions of stars, sun is one star, and the solar system is the system which is formed by our sun, and it is located in Milky Way galaxy. Galaxy is a system of millions or billions of stars together with a gas and dust cloud. These are the nebulas which form the galaxy. The nebulas, which are the source of formation of the galaxies, some of their components are left behind, and these are held together by gravitational attraction of all the stars. Now our solar system consists mainly of one star, that is our sun, which is located at the center over here. Then there are 8 planets. We have studied in our school that there are 9 planets, but Pluto was removed from the classification of planets, and it was later classified as a dwarf planet. The reasons behind it are there, which we will discuss in the videos when we make videos on the universe. But Pluto is not a planet right now, it is a dwarf planet. Now in our solar system there are 5 recognized dwarf planets, but this count may increase based on the recent findings. There are also 181 natural satellites. Again, this quantity can also increase because of the increased power of the telescope, as well as the telescopes which are there in the space. They are finding new satellites of planets. Then in our solar system we also have asteroids, meteoroids and comets. And apart from them, there is this Kuiper belt and Oort cloud. So these two might be new things which you might be hearing today. So let's try to understand here. This is our sun, and very close to the sun we have this planetary region. So in this region we have our Mercury to Neptune. Remember, Neptune is the furthest planet. Then after this Neptune we have a region which is called Kuiper belt. These are the regions where it is supposed that there are very small dwarf planets or very small objects which are revolving around our sun. There are several of those dwarf planets which are found, and some of them are in the process of being calculated. And further away we have this Oort cloud. These are very far located objects, but still they are under the influence of gravitational force of our sun. Therefore they are part of our solar system. And remember, most of the comets, which has a very long life cycle of like 76 years or 80 years, during which they revolve around the sun. So they take around 80 or 70 years for one revolution around the sun. So they are considered to be originating from these Oort clouds. See, it is said cometary nuclei. So those comets, they generally originate from these Oort cloud, where they are dislodged from these Oort clouds due to some gravitational anomaly of some process occurring in the other stellar system or some other regions. They are dislodged from their orbit and they come towards the sun, and they form a very high elliptical path. That is why they have such high revolution days. Now the first planet is Mercury. Mercury looks something like this. Mercury is the smallest and the closest to Sun. It takes 88 Earth days for revolution around the Sun. So this Mercury, it takes around 88 days for revolving around the Sun. Then the second planet is our Venus. So Venus is twice the distance from the Sun as Mercury. It looks something like this. It's Earth's twin. So generally Venus is called Earth's twin because it has same size, same mass and almost same density. So remember, Mars is not called the Earth's twin, it is the Venus which is called Earth's twin. Then we have Moon, our own Moon, which rotates around Earth in 27.3 days. We have our Earth, of which we are well aware, so we are not including in this count. Then we have Mars, which has these dark red patches which we can see over here, and it is called red planet, and it is believed that life existed on this planet in the past. Several millions of years ago there was life, and recently NASA has also found some evidence of microbial life on these planets. Next is Jupiter. Now Jupiter is the largest planet in our solar system. It is mainly gaseous, formed of hydrogen, helium and methane, and it has circular light and dark bands around it. So here you can see these are the circular bands, and these bands are mainly formed because of Coriolis force. So we know that Coriolis force is responsible for many phenomena on our Earth. It is also similarly responsible for many other phenomena occurring on other planets. So these kind of winds, they are caused by Coriolis force. Remember, Jupiter rotates at a very high velocity, and that is why it has a very strong Coriolis force. Next bigger planet is Saturn. Saturn is famous for three rings around it. So there are these three rings. These three rings are basically composed of small icy objects. It is the second largest planet after Jupiter, and it takes around 29.5 years for revolution around the Sun. We can see that one revolution takes almost 29.5 years, which is a very long duration. Next is Uranus. Uranus looks something like this, and Uranus is bluish green planet, so it has a bluish color. The reason is that it has methane in the atmosphere. Similarly, this is our Neptune. So Neptune also has a lot of methane in its atmosphere. Now the methane, it absorbs red color. It absorbs the red spectrum of the visible light, and therefore only the green and the blue parts of the visible light are there, and that is why we see this as blue colored, both of these planets. It is 50 times larger than Earth. It rotates in clockwise direction, retrograde, east to west. Neptune. It is called twin of Uranus because it has very similar properties, and they were discovered more of because of the influence of one planet on the other. The Neptune, it used to influence the revolution of Uranus, and that is why it was calculated mathematically first and then it was observed later. Again, it has large amount of methane which absorbs the red wavelength, that is why it appears blue in color. The last is Pluto, which is not a planet, it is a dwarf planet. Remember, it has been removed from the classification of planet due to certain classification changes. It is smaller than Earth, and it takes around 247 years to revolve around the Sun. So it is very far away from the Earth and in fact the Sun. Now here we see some statistics of all the planets, which would help you in recognizing some characteristics. So if we see the distance from Sun, we can clearly see that as we go from inner to outer planets, the distance increases. We can see that till here the increase is not that much, but here we can see that there is very high increase in distance. If we see the diameter, then we can see that Venus and Earth, they have almost similar diameter as we have discussed. That is why these two are twin planets. If we see Saturn, then it is smaller than Jupiter but very close. And after that, Uranus and Neptune, they have almost similar diameter, and that is why these two are also called as twin. Now if we see the rotation time, that is the time which a planet takes to rotate around its own axis, you will see that these are the days in compared to our Earth days. So if we want to multiply or see the time, then we have to multiply this by 24 hours because these values are in Earth days, that is 24 hours. So if you see, Mercury takes around 58.66 days for rotation on its own axis. But if we go to Venus, it takes 243 Earth days. So it has the highest rotation time. Remember, this is the rotation time. And if we see, its rotation time is actually greater than its revolution time, which is a very unique characteristics for any planet. After that, we see the Earth takes 1 day to rotate on its axis, then Mars, which has almost similar time for rotation around its axis. Then we have Jupiter, which is less than half of the day on Earth. And we can see here that as the planet is larger, the rotation time is smaller. So Jupiter, which has the highest size, it has the least time for rotation around its own axis. Saturn, which is the second largest planet, it has second smallest time for rotation. And then we can see these two. Here also Uranus, which is bigger than Neptune, we can see that Uranus has 0.71 while the Neptune has 0.67. So this is actually faster than Uranus, even though Uranus is slightly larger. There is a very unique characteristics of Uranus rotation also. It rotates on a very high inclined axis. Like Earth rotates on 23, so its rotation axis is very high. Now if you see the average temperature, here we can see that these are the positive average values and these are the negative average values. We can see that the hottest planet is Venus and not Mercury. While if we go down, we can see that the coldest planet is Uranus and not Neptune. So this is a very interesting characteristic. Normally we would believe that Mercury is the hottest planet, but in reality it's Venus, and the reason is greenhouse effect. The Venus has a lot of carbon dioxide in its atmosphere. If I'm not wrong, it is around 94% or 96% of the total Venus atmosphere is made of carbon dioxide. That is why the solar radiation which reaches the Venus, it never escapes it, and that is why the temperature is very high. While here Uranus, because of its unique rotation, one side of the Uranus, it rarely or almost never faces the sun. Therefore, the temperature is very low. If you see the surface composition, the first 4 planets are rocky and next are gaseous. And if you see the rings and moons, so we can see that the first 4 planets, they do not have rings. But the later planets, even Jupiter is supposed to have rings. The Saturn rings are very prominent, which we can see from telescope from Earth. Others have very less significant rings compared to the Saturn, but they do have rings. And we see the largest number of satellites are with Jupiter, that is around 60. Then we have Saturn, which is around 31. Then we have Uranus around 27. And then Neptune, there are 13 moons. But these are subject to changes because new moons are also discovered over the time. Mars has 2 moons, while our Earth has only 1 moon. And here we see the distance from Earth, the distance it will take to reach each of these planets. But this is only an average time or an estimate time, because based on the position of the planets in the revolutionary path, this value will differ. Mostly, Venus is the closest planet to Earth and not Mars. Venus is the closest planet after Venus. Sometimes it's Mars, sometimes it's Mercury, based on the position of these planets or orientation of these planets in their revolution. Sometimes Mercury may be on the other side of the Sun compared to Earth, so the distance will be larger compared to Mars. Sometimes the Mars will be further away and Mercury will be closer to Earth. So there is this difference, and after that we see that Jupiter is furthest, then Saturn, then Uranus, and then Neptune. So let's have a quiz. So if you are watching this stream and you are seeing these questions and you want to participate and select one of these options. So when I will launch the poll or launch the quiz, you can use this option. You write in the chat exclamation OPT, and then at this dash you can select one of these options. For example, if you feel that B is the answer, then it will be explanation OPT and then B in small. So if you do this, you will select D, which will be reflected. So let's start the poll. and it is not working. Some reason our pole is not working. Right. Okay, the poll does not seem to work. I will see why it is not working. So let's see what is the question. The statement in solar system extends to Pluto only. This statement is false because we have seen that after Pluto we have this Oort cloud and Kuiper belt. So all these things are there even after Pluto. So our solar system extends well beyond the Pluto. So this is false. The solar system has 8 planets. This is true. The first 4 planets are rocky and the last 4 planets are gas giants. This is also true. Mercury is the hottest planet. Now this statement is false. So 2 and 3 are the only right statement. Therefore B would be the right answer. Okay, moving on to next slide, we have another question which says which of the following statement is true about our solar system. So Neptune, first option is Neptune, which says that it is the coldest planet. Then it's that Venus rotation time is greater than revolution time, and the third option is Neptune has rings like Saturn, and Mars is closest planet to Earth. So these are the 4 options, and here these are the 4 statements, and here are the options. But I don't think the whole function is working. So let me see. Neptune is the coldest planet. So we have seen that Uranus is the coldest planet because of its orientation of rotation. Therefore, this statement is wrong. Venus rotation time is greater than revolution time. This is true. It takes around I think 240 days for rotation and 222 something like that for revolution. So the rotation time of Venus is greater than revolution time. Neptune has rings like Saturn. Yes, it has. They are not much prominent, but it does have rings. Mars is closest planet to Earth. This statement is again wrong. We have seen that Venus is the closest planet to Earth. So again, 2 and 3 are the right statement. Answer will be B. Now let's see Earth's shape. What is our Earth shape? Generally we call it as sphere, but technically it is called geoid. This is the Earth shape, and what it means that it is flat on the poles, while it is also called as oblate sphere. So geoid or oblate, these both are correct terms. And what does it means that if we take these dotted black line as the sphere, so our Earth would be something like this. Here we can see that at the North Pole and at the South Pole, we see that is departing from this sphere. It is slightly lesser than it should be, and at the equatorial region we can see that it is slightly bulged. So at the poles it is slightly compressed, and at the equator it is slightly bulged. The reason is that when the Earth was formed, there is this centrifugal force. Even today there is this centrifugal force because of rotation of the Earth. For each planet, this centrifugal force, it causes this bulge at the equator. Therefore, what happens that if you see the equatorial circumference, this is the circumference around the equator, while this is the polar circumference, that is the circumference of a longitude. We will see that the equatorial circumference is slightly larger than the polar circumference. So do keep this in mind that the equatorial circumference is larger than the polar circumference. These are the values, and equatorial diameter is again larger than the polar diameter. So you should know what is the difference between circumference and diameter. Diameter is the direct distance, while circumference is the distance on the surface. So our Earth's surface is geoid or an oblate sphere. Both of the terms are used. Now, when the Earth was there, and initially there was a lot of debate whether the Earth's surface is flat or it is this spherical shape. So there were a lot of people which believed that the Earth's surface was flat. Even today, there are people who believe that the Earth's surface is flat. In fact, Right? Just in last month, there was a conference where people had tried to prove that Earth's surface is flat. So there were certain evidences which were given over the centuries to prove that our Earth is spherical. Remember, this is before these satellite images were available to us. Everything was based on calculations. So the first and the foremost undeniable uh, proof that our Earth is spherical was by a circumnavigation of Earth. There was a person called Ferdinand Magellan and his crew. They went around the Earth and they were first to travel around the Earth. So they started going in one direction and reached the same position without changing their direction. So this proved that our Earth was not flat but spherical. Second came the circular horizon. So what happens when there is a ship which is approaching? Now because the sea surface is very plain, so if the earth was flat, then the ship should be visible completely when it is closer to us. But what is observed over the seas, that when the ship is approaching you, first you will see the mast, the top of the ship. Once this mast appears, then after some time you will see the whole ship body will appear. So this is also a proof that our earth is spherical and not flat, because if it was flat we would see this mast somewhere higher, because whole ship should be seen simultaneously. Distance horizon from ship or mountain looks curved. Curve increases as height increases. So here also there is another point. We just discussed this point, ship's visibility, where mast of the ship is seen first over horizon, then whole ship is visible. Here in this point, what they are saying, that distance horizon from ship or mountain looks curved. So if we are standing on the shore and looking at the sea, then at the horizon you will see that it looks like curve. It does not feel like a straight. So if you are standing high up in the mountains, even then when you look at the horizon, it appears as curved. So this curve, it increases as higher you go. And this is a proof that Earth is in fact spherical or not flat. Some other evidences were also given. The first is sunrise and sunset. Sun rises and sun sets at different times in different places. And as the earth rotates from west to east, the places in the east see the sun earlier. So it is Japan which is called the land of the rising sun, because it was considered that here the sun would be seen first, and then over time the rest of the parts of the earth will see the sunrise. So because of this delay in time for seeing the sunrise, we can consider that our earth was spherical. Then during the eclipse, not only lunar eclipse but solar eclipse or eclipse of other planets, we see our shadow on moon or shadow of other planets, and they are not linear, they are curved. Only a spherical object can cause such type of shadows. So this was a very good proof that our earth is also spherical. Then another is all planetary bodies are circular. So whatever was observed from the telescope, from the weaker telescopes which are present a few centuries ago, so all those planetary objects were also visible as spherical or circular. So if all those are circular or spherical, then our earth should also be spherical. Seventh was driving poles on level ground on a curved earth. Driving poles of equal length at regular intervals on the ground, they do not give a perfect horizontal level due to curvature of the earth. So what here it is trying to say, that if we take some objects which are of equal height and we place it in a line on a flat surface, as you can see over here, these poles are of same height and they are placed on the sea surface, and they are stretched over a very long distance. So they are spread over a very long distance. But if you see, the height is not basically a straight line because of the curvature. You can see that the line is actually bending downwards. This is also effect because of the spherical nature of our earth. And then last, it was the aerial photographs. When there were aeroplanes available, when there were satellites available, the photographs from the space, it gave the actual or true image of our earth, and in which we saw that it is spherical. Now let's see the earth's movement, that is the rotation and the revolution. So we will try to discuss some key points in this. Although it is a very general topic which you would think that you know, but there are certain specific things which is discussed in this chapter which are not commonly known. So do focus on it. Rotation. Earth moves on its own axis. We know that it rotates on its own axis. It is around 23.45 degrees. Rotation time is 23 hours, 56 minutes and 4 seconds. Because a solar day is longer than a sidereal day. So there are basically two types of rotation, or two types of days basically, sidereal day and solar day. Our sidereal day is slightly less than 24 hours and our solar day is exactly 24 hours. So let's try to understand what is the difference between these two types of days. So suppose this is our Earth and this is rotating on its own axis. Over here, this is our North Pole. So when it is rotating, suppose you are here. Now the time that this Earth will take to come back to this position again will be 23, 56 minutes and 4 seconds. So here it has completed one rotation. Now how is this measured? This is measured with respect to a distant star. So this is one complete 360-degree rotation on its own axis. But because we are revolving around the sun, our point, the region pointing towards the sun, that is directly beneath the sun, that will change because of our revolution. So what happens in the solar day is day that suppose you start over here, then you go around your rotation axis and then you again come to a point that you are directly beneath the sun. So initially this line was directly beneath the sun, but because of revolution of our Earth around this orbital path, our Earth has slightly moved. Therefore, we have to cover slightly more to bring that point directly under the sun, and that is why we cover 1 degree more. So the 24 hours for our Earth is in fact the time our Earth takes to rotate 361 degrees and not 360 degrees. So sidereal day is the time the Earth takes to rotate 360 degrees, while solar day is the time Earth takes to rotate 361 degrees. Why 361 degrees? Because it is calculated from the point here which is directly under the sun to the next time when this point comes directly under the sun, and this point changes, which you can see over here. Here this point is directly under the sun and here this point is directly under the sun. So we have to compensate that additional path by rotating 1 degree more, and that is why there is a slight difference between sidereal day, which is 23 hours 56 minutes and 4 seconds, and solar day, which is 24 hours. Rotation speed is 1670 km per hour. So this is the speed at which our Earth is rotating. The side which faces the sun is day and the side which faces away is night. This is very obvious that this side which is facing the sun is experiencing day. This side which is facing away from the sun is facing night time. If we talk about revolution, it takes 365 days, 6 hours and 9 minutes. Now, this is very well known term. That is why we have our leap day. So if you see, this is our 6 hours extra. So because it is 6 hours extra, if we increase it 4 times, it will make one complete day. And that is why after 4 years, we add an extra day for compensating these 6 hours. But there is also this 9 minutes. Now these 9 minutes also increased a day. We are overcompensating. And that is why for each 100th day, we do not have a leap year. If we see 100 is divided by 4, so ideally 100 should be a leap year, but it is not a leap year. Then we have this orbital speed, which is around 29.29 to 30.29. So that is around 30 km per second. So our Earth is revolving around the sun at this speed, 30 km per second. Again, let's take a quiz. Which of the following statement is true about our Earth? Earth takes exactly 24 hours to rotate 360 degrees on its axis. We have seen that this is not true. It takes 24 hours to rotate 361 degree on its axis. Earth is geoid shape with polar radius greater than equatorial radius. Again, this statement is not true. Earth is geoid shape with equatorial radius greater than polar radius. Therefore, this statement is also not true. Earth's shadow shape on moon proves that Earth is spherical shape. This statement is true. Therefore, C will be the answer. Well, I guess the question part is not working. I will check why it is not working. I think one of my software is not working. When it will be working, you can ask me questions. You can write in the comments this exclamation question and then your question. So when you do this, ideally I should see your question right over here. But somehow it is not working right now, which I will check after this video. So that we can use this facility for answering your questions. Now let's see the effect of revolution of Earth. So our Earth, which revolves around the Sun, due to which we have certain specific characteristics, and let's see those characteristics. So here is our Earth, which is rotating around the Sun, and we have divided it into three views. The first is side view. This is, we are viewing it from the side. This is our North Pole, this is our South Pole. This is the front view, that is, we are seeing from the Sun side. And this line, it indicates the region of the Earth which is directly under the Earth. And then here is the top view where we can see the location of our Earth in the orbit around the Sun. So right now it is December, it is closest to the Sun. Yes, in December, Earth is closest to Sun. And at this time, the Sun is located over Tropic of Capricorn. That is why there is summer in the southern hemisphere, while the northern hemisphere is facing away from the Sun and there is winter. Here you can clearly see in these two that the Sun is over the southern hemisphere over Tropic of Capricorn. Now what happens when this moves? You will see when our Earth, it starts to move from December and comes towards the March. We can see how this Sun is moving up. And here we can clearly see this is the equinox position. This position is called equinox, and here it is called winter solstice in terms of northern hemisphere. Otherwise it is called December solstice. That is, Sun is at the southernmost location. Here we see that it is located on the equator. The Sun is right over the equator, and one thing we can see that the line of illumination passes through the South Pole to North Pole. So at this time, around Earth, the days and night are equal. Everywhere on this planet, on Earth, we will have equal days and equal nights. That is 12 hours day and 12 hours night. And this occurs only twice in a year, when we have March equinox and when we have this September equinox. So these are the only two times when we have 12 hours days and 12 hours night. Now after this, from the March position, our Earth, it moves towards this June position. This is our solstice, June solstice. And at this position, what happens? You can see that the Sun is located over Tropic of Cancer. And right now you can see that the South Pole, it is facing away from the Sun. There is no sunlight over here. There is 6 months of darkness. That is 6 months of night at the Southern Pole. Here at the North Pole, it is facing towards the Sun. There will be 6 months of daylight. That is 6 months of day. We can clearly see that how this tilted axis of our Earth, as well as the revolution around the Sun, it is influencing the length of the day based on your latitude. If you are at the North Pole, that is 90 degrees, or at the South Pole, that is again 90 degrees south, then you will have 6 months of sunlight, 6 months of continuous darkness. Again, when our Sun will move from this June to September equinox, what we will see that the Sun will be over equator, and we can clearly see again the line of illumination. It passes right from North Pole to the South Pole. Again 12 hours days, 12 hours night. So this is how the tilted axis of our Earth's rotation as well as our revolution around the sun, it changes the length of day. So here we can see this is June solstice, this is December solstice, and we can see that during this time we have equal days and equal nights on both of these. Here in the this is the equinox, and here we can see that there is equal day and night, and similarly here also there is equal day and night. But when we come here, this is solstice, we can see this is our north pole, this is our south pole. So this south pole is not receiving light, it will not receive for continuously 6 months. This is June solstice, and similarly things are reversed in the December solstice. The south pole is exposed to 6 months of continuous daylight or sunlight, while north pole is exposed to continuous 6 months of darkness. Here is an interesting figure. If you see, here we have this circle, this red colored circle. This red colored circle is our Arctic circle, and the Arctic circle is nothing but the margin where you will see that there is no sunset or sunrise once our Earth is on this solstice. So what it means is basically when you are in June solstice, so our sun is in the northern pole. So in the southern hemisphere, beyond the Antarctic circle, on that day, you will not see sunrise. And when it is this December solstice, then you can see this is our December solstice. So the region of the Earth which is beyond the Arctic circle, it will not have a sunrise on that day and days beyond that until it reaches over here. So this Arctic circle, it is basically the dividing line where we have continuous darkness. The duration of the darkness varies on the latitude, but at least one day you will not have any sunrise. So this region over here, for one day in a year, it will not have any sunrise. Now we have already seen varying length of day and night, mainly due to inclined axis of Earth. So our Earth, it rotates at 66.5 degree with orbital plane of Earth. So the 23.35 was with respect to vertical, this angle is with respect to the orbital plane. So here we have this plane with respect to our the plane which is joining the center of our Earth and the Sun. So with respect to that, so that is this angle from here to here. So to understand this, suppose this is our center over here and we draw a line like this over here. Then the angle 66 would be something like this from here to here. But what we saw earlier, which was like this, if we draw a vertical, then the 23 degree would be something from here. So these are the two distinctions between these values, the 66.5 degree and the 23.45 which we saw earlier. If axis was 90 degree, all parts of Earth equal day and night. So if this axis was 90 degree rather than inclined, then throughout the year we would have equal days and equal nights all across the planet. But because it is inclined, we have variable length of days and night. Now here we are seeing varying length of day in winter for northern hemisphere. So at Arctic circle, that is 66.5 degree north, 22nd December, the sun never rises and there is darkness for the whole day. So here we see that the regions beyond this will have at least one day when there is no sunrise. The number of days will actually increase when you move from the Arctic circle towards the North Pole. So at the North Pole we have 6 months of darkness. At the Arctic circle we have 1 day of darkness. Beyond the Arctic circle, the number of days with complete darkness increases. At North Pole, 6 months of darkness, and we can see why, because our North Pole is facing away from the sun. And if you see the summer, then at Arctic circle on 21st of June, sun does not set daylight for 24 hours. So here what happens, that there will be at least one day at the Arctic Circle, where there will be no sunset. Sun will be available 24 hours. And the number of these days will increase as you move from the Arctic Circle towards the pole. So at the pole it is 6 months, at the Arctic Circle it is 1 day where there is 24 hours of sunlight. Region north of Arctic Circle is called land of midnight sun because of 24 hours of sunlight. Here you can see sun at midnight, therefore it is called land of midnight sun. At pole we have 6 months of sunlight. So here you can see sun never sets beyond this for at least 1 day in a year. Now here we will see the altitude of midday sun. We have seen the variable length of the day, but here we will see that the sun's position in our sky, it changes based on our seasons or based on our location in the orbital path. So here is a GIF where we can see that during the summer solstice, this is with respect to northern hemisphere. During the summer solstice, the sun goes as high as this. But during the winter, from the northern hemisphere perspective, that is during the December, the sun is over Tropic of Capricorn and therefore sun is seen much lower in the sky. So the altitude, that is the height which the sun can reach in the sky, it decreases in the winter while it is at the highest in the summer. So here is an example. We can see that during the winter the sun rises over here, it follows this path and then it sets over here. During the spring and fall, the sun will rise over here, it will go to a much higher height and then it will set over here. And during the summer solstice in the northern hemisphere, you will see that the sun will rise to a very high height compared to all of the days in our year and then it will set. So we can clearly see that the height of the sun in our sky, it also changes because of our inclined axis of rotation and our revolution around the earth. So remember, both of these factors are important. Just inclination of our axis will not cause this variation. Revolution is also important. Now here we have taken a photograph. This is basically from a park in New York, and what they have done, they have taken some sample days and they have plotted the highest point of sun on that day, and you can see the path it makes. In June it reaches the highest height over here, in April, September it is over here, and in December it is at the lowest. So you can see this is the actual path of sun in our sky. It is like an infinity or like 8 shaped. Let's see this further with some figures. So due to Earth axis of 66.5 degree with orbital plate, at equinox, that is when the sun is shining over the equator. Sun is vertically over the equator 2 days in a year, usually 21st March and 21 September. Remember, these dates vary because of the leap day, which cause these days to change a little bit. Equal days and equal nights all across the globe. So we have already seen that during the equinox we have 12 hours days and 12 hours night, and if we see this blue line, it indicates the sun's path during the equinox. This is at 50 degree north latitude, where we can see that it follows this path. This is at the equator, so we can see that it is right overhead. And a very important phenomenon occurs during this time. During the equinox, there are certain locations on the equator where you will have no shadow at the noon. Because the sun is vertically aligned with you, there is absolutely zero shadow. So this is a very interesting phenomenon which occurs on particular day when sun is right over the equator, there is no shadow. And then here we can see that at equinox, the sun is right on the horizon at 90 degrees. So you do not see sun rising up, you do not see sun setting, it is right at the horizon, just at the boundary throughout the day. Now in summer or June solstice, that is 21st of June, sun is over Tropic of Cancer for 1 day in year. North hemisphere has longest day and shortest night, and southern hemisphere has shortest day and longest night. So if we see, this is our June solstice. This color indicates June solstice, and here we can see that at 50 degree north, the sun has reached the highest point. At the equator, if you will see that the sun is slightly lower, it has moved slightly north because the sun is in the northern hemisphere. And at the 90 degree, at the pole, you will see that the sun is a little higher in the sky. It has reached its highest point. In winter, that is around 22 December, sun is over Tropic of Capricorn for a day in year. Northern hemisphere will have shortest day and longest night. Southern hemisphere, longest day and shortest night. So if we see it from the perspective of northern hemisphere and we see December solstice, then we can see that at 50 degrees, sun is at its lowest position. This is the path which sun will take. It is very close to the horizon, so it does not go very high in the sky because our earth, our northern hemisphere is facing away from the sun. And that is why it appears at a very low level in our sky. At the equator, we will now see that the sun has moved slightly southwards because earth is in the southern hemisphere, and at the equator we can see it is higher, not as high at the equinox, but still the sun is higher in the sky, but it is on the southern side. And at the poles, there is no sunlight. At the winter solstice or December solstice, you will see that the North Pole we do not see any sunlight, and therefore you do not see any line corresponding to the December solstice in this figure. Now we also know that because of the inclined rotation axis and revolution, remember again both of these things are important. Just inclination of our earth does not give us seasons, it is also the revolution. Therefore both of these factors, they give seasonal changes, season caused due to rotation on a tilted axis. Summer, sun is higher in the sky than in winter. Sun rays are vertical, more intensity in the solar rays. So we know that sun is higher, it is vertical in the summer, and the sun rays, they are vertical. Therefore, they are not spread out, they are direct, they travel less distance in the atmosphere, therefore there is less dispersion. And that is why the amount of heat received by our earth is also higher. Days are longer, so we have more sunlight. That is why we have more temperature, more warmth or more heat which is received during the summertime, because sun is higher in the sky. It is in the sky for longer time. You can see the path here. This path is much longer than this path from the perspective of northern hemisphere. Winter, sun is lower in the sky, much lower. The light has to travel a very inclined path. There is much dispersion, diffusion, scattering in our atmosphere, and that is why the sunlight intensity reduces because of the scattering and the diffusion. Oblique rays, low intensity, do not provide much heat, days are shorter, and there is less sunlight which is reaching the region. Now in GC Leong we also see that it mentions dawn and twilight. So let's try to understand what is dawn and what is twilight. So dawn is basically brief period before sunrise and full daylight. So this is the duration when the sun is not above the horizon. Here you can see that when it is approximately between 6 degree to 0 degree, the sun is between 6 degree to 0 degree. This is our horizon and this is up. So that time is called dawn or dusk. So during the sunrise, when the sun reaches this position, it is still not at the horizon, it is still not visible. So from here to here, you will say it is dawn. Now here you can see sunrise is the point where you see first glimpse of sun, that is sunrise. This is dawn. We cannot see the sun over here. Now dusk, if you see, then sunset is the last moment where you see the last part of the sun is visible. Its last part is visible. That point is sunset. And again, when it crosses this 6 degree mark, then it is called end of dusk. So this duration from the horizon towards this 6 degree mark is called dusk. Here it is said, moment when the center of the sun is exactly 6 degree below the horizon. Sunrise, sunset, moment when the first part of the sun becomes visible. So here when the sun is visible, and here we are measuring it from the center of the sun. So the center of the sun should be below this 6 degree mark. Again, dawn is brief period between sunrise and full daylight, and twilight is brief period between sunset and darkness. During dawn and twilight, Earth receives diffused or refracted light from the sun. So refraction and diffusion occurs because of our atmosphere. Remember, there are a lot of dust particles, there are clouds in our atmosphere, there are molecules in the atmosphere which scatter, which diffuse, which refract the sunlight. And because of that, that sunlight could reach the earth even though we are not in direct line of sight of our sun. At equator, refracted light duration is small because the sun rises and sets in a vertical path. Here you can see that the sun path is vertical, and therefore there is very small gap between the sunrise and the dawn, and that is why we see that the reflected light duration is smaller. At higher latitudes, we will see that this path is much inclined. Here we can see in both the hemispheres, even the sunset is also inclined. So that is why there is larger duration for which there is refracted light which is coming to our earth in those regions, and that is why they are slightly longer. At pole the duration is highest. At pole the duration of dawn and twilight is highest. Here is again a quiz. Which of the following statement is true? Earth's inclined rotation axis and revolution causes variation in day length and season. So here we have both the terms day length and season, and this statement is basically true because both of these things, they combine together to give us this variation in day length as well as seasons. On solstice, sun is over equator. This statement is false. We know during the solstice, sun is over Tropic of Cancer or Tropic of Capricorn. On equinox, every region on earth has 12 hours day and 12 hours night. This statement is in fact true. 1 and 3 are right statements. Again, there is one more question. Which of the following statement is true? On June solstice, sun never sets in region on and beyond Arctic Circle. This statement is in fact true. In southern hemisphere, sun is highest in the sky in winter of southern hemisphere and lowest in the sky in summer of southern hemisphere. This statement is in fact wrong. Even in the southern hemisphere, sun is highest in the summer of southern hemisphere, which will be winter of northern hemisphere, and vice versa for this. So this is actually wrong. On December solstice, sun is over Tropic of Capricorn. This statement is again right. I will make this work. I don't know why it is not working today. Now let's see the last part of this chapter, that is latitude and longitudes. So we know that latitudes are nothing but the circular lines which are parallel to equator. Here we can see these are the circular lines which are shown over on a globe as well as other maps. So these are basically parallel to the equator. Latitude is the angular distance of a point on the Earth's surface measured in degrees from the center of the Earth. Now this is an interesting thing. If this is our plane, our Earth's plane, then this degree is the latitude. So if you take the equator as 0 degree, then the angle it makes, the angle that region will make, that will be its latitude. So this is how these latitudes are given their values. 90 degrees making right angle with this plane, the plane where there is center of Earth and the equator. So that plane is making 90 degree with the North Pole, and that is why we have 90 degree at the North Pole. Here we have an example of New Orleans, and it is making 30 degree with this plane, the plane which is having our center of Earth as well as equator. That is why it has 30 degree latitude. These lines are parallel to equator and which lies midway between the poles. So the equator lies midway between both the poles, that is North Pole and South Pole. On a globe, they are actually circles becoming smaller polewards. So if you see on these globes, they are circles, but their diameter is decreasing as you are moving away from the equator. Remember, equator has the highest diameter in the latitude, and the pole, the 90 degree, has 0 radius. The equator represents 0 degree, and the north and south pole are 90 degree north and 90 degree south respectively. Then if you see some further information about the latitudes, so we have seen in the beginning that our Earth is oblate shape or geoid shape, which means it is flatter at the poles and little bulged at the equator. And that is why the distance between the latitudes varies. Earth is flatter at polewards, the distance is 1 degree, latitude increases. Because it is flatter, so the distance between 1 degree, that is 29 degree north and 30 degree north, will be little higher than 0 degree and 1 degree north. So at equator, 1 degree means 110 kilometers, and these values at Tropic of Cancer and Tropic of Capricorn, we can see there is slight increase now. It was 567, here it is 948, and at poles 1 degree means 111.699 kilometers. So for approximation, we take an average of these values and we use 111 kilometer per degree. So for latitudes, 111 kilometer per degree latitude is the distance. So distance between two latitudes, that is if we take 61 degree north and 62 degree north, then the distance between these two latitudes on the Earth's surface will be 111 kilometer. These are the important latitudes. We already know Tropic of Cancer, 23.5 degree north. This is the region where the sun is highest. The sun does not go above this. This is Tropic of Capricorn, 23.5 degrees south. So this is the lowest, or this is the southernmost latitude over which the sun goes. It does not go beyond this. Equator is 0 degree, that is in the middle of North Pole and South Pole. Arctic Circle, 66.5 degree north. This is the region where there will be at least one day in a year when there is no sunrise and no sunset. And similarly, Antarctic Circle, here also there will be at least one day where there will be no sunrise and no sunset in a given year. Now let's see the longitude. Longitude are series of imaginary semicircles which run from pole to pole. So these are imaginary semicircles. Remember, these are not complete circles, these are semicircles. And they run from one pole towards another pole. Distance between longitudes varies. So if you see these two longitudes at the equator, they will have different distance. This is the distance, but at the poles they merge together. Here we can see at the poles all these longitudes, they merge together. Therefore the distance is 0 at the North Pole. But here at the equator they have certain value. What is that value? 111 kilometer. So similar to the 1 degree latitude. So at the equator, 1 degree longitude means 111 kilometer. Now there are total 360 longitudes, basically representing the 360 degree value. And remember one thing, it starts from 180 degree east to 0 degree to 180 degree west. But 180 degree east and 180 degree west are the same line. Here in this view you can see this is 170 degree, this is 170 degree, and we have only 180 degree. There is no second 180 degree. Therefore this 180 degree represents both 180 degree east and 180 degree west. So do remember that. Remember, this is 170 degree west and this is 170 degree east. But this 180 degree is common to both and it is called international date line. So basically the date changes over here. So if you are in this part, then you will have one day ahead of this part. So here if you are there and it is like 4th of January, then this region will have 3rd of January. This will be lagging one day behind. That is why it is called that the sun rises from Japan. So remember this, if sun rises from Japan, which is why it is called the land of rising sun, then the day starts from Japan. So Japan and Russia, these are the regions where the day will start, and US and Canada will lag behind. They will be a day behind Russia and Japan. There is international date line we have discussed. Prime meridian is another important longitude. It passes through Royal Astronomical Observatory, Greenwich near London. So this is because they were the society which gave those the concept of prime meridians. That is why they gave the 0 degree to this London, because they were located here. So because they give this concept, they took the 0 degree for themselves. So there is no reason for calling this line as 0 degree as such. Any longitude can be called 0 degree without making any change. Now these longitudes, they are used for calculating regional time. We know that 360 degree of longitude means 24 hours because our earth rotates on its axis in 24 hours. Therefore 1 degree longitude is equal to 4 minutes and 15 degree longitude is equal to 1 hour. So if you divide this 360 with 24 hours and each hour having 60 minutes, you will get 1 degree longitude equal to 4 minutes. And if you multiply this by 15 both sides, then you will have 15 degree longitude equal to 1 hour. So in 1 hour you cross 15 degree longitude, or if you are on a map and you cross 15 degree longitude, you know that you have moved 1 hour either ahead or backwards. For calculating local time with prime meridian, so we have prime meridian over here. You can see this is our prime meridian and here is our equator, somewhere they meet over here in the Gulf of Guinea. Now going back to this 0 degree, we can see that it is right over this London. Now if you are located in, suppose, India, and you want to find the time compared to the 0 degree, then what you will do, you will take the longitudes. You are away from this 0, so you will take that value and for each longitude you will multiply 4 minutes and then you will add it to the time of London. That will be your time. You will be ahead. Remember, this region will be ahead of London while this region will be behind London. Similarly, if you are on this side, then you need to subtract. That is, if you are moving on this side, then you need to subtract the time. If you are moving on this side, then you need to add that time. International date line. Now here we see international date line, and remember, this is not a straight line like other meridians. This is very curved, and it was twisted and curved like this to accommodate certain regions of the country which were lying on this boundary. So if it were a straight line, then some countries which are lying over here, in one part of that country there would be 1 day and another part of that country would be another day, based on the side they are with this respect to international date line. This was not acceptable to those countries, and that is why it was curved like this to accommodate the boundary of those countries. Therefore each country has all its regions in one time zone. International date changes by 24 hours. So if you cross this, the time will change by 24 hours. If you are moving from here towards US, you are losing a day. So if it is Tuesday on this side, you will have Monday on that side. If you are moving from this towards here, you will go to the next day. That is, if it is Monday over here, you move over here, you will be in Tuesday. The eastern side of the date line is 24 hours ahead of western side. So this side is I think this statement is wrong. This is the western side. I need to check why it says eastern side. This side is actually right. Now this side is ahead and this side is behind. So I think the western side of date line is 24 hours ahead of eastern side. The international date line is the mid-Pacific curves from normal 180 degree meridian at the Bering Strait. So here we can see that it is curving here at the Bering Strait to accommodate this region of Russia. Then Fiji, Tonga are countries over here, and there are other islands. So to prevent confusion in those regions, this has been curved like this. Now to understand this distance variation, if we take our Earth, and if we take like here we have divided our Earth based on the longitude and latitude. So if we take one of these boxes, then at the equator we will see that they have almost similar length and breadth. But when we go to the higher latitude, you will see that the height will remain almost similar, but this distance, horizontal distance, decreases because the distance between the longitude changes, and therefore you will see that it has decreased. So here the distance between longitudes will be 111 point something, and here as the latitude increases, you will see the distance between the longitude is decreasing. It is 0 at the poles. Again, similar thing is depicted over here. We have taken a box over here at the equator at 51 degree and then at 90 degree. And then we can see what 1 degree change means. 1 degree change here means 11 degree for the longitude distance, and this is for the latitude distance. Again, at 51 degree, 1 degree is around 111, very close to this value. And again, for the longitude, the distance is same, but for the longitude distance, we see it is 0 kilometer. Here it is 70 and here it is 111. This distance indicates the distance between longitude and this distance indicates the distance between latitude. Here we have seen 1 degree. 1 degree is divided into minutes. So there are 60 minutes in 1 degree. And again, it says that 1 minute represents almost 1.855 kilometers. And then again, 1 minute includes 60 seconds. And then 1 second is around 31 or roughly 30 meters or 31 meters. So this is between longitudes and this is between latitudes. Again, there is one question: which of the following statement is true? Latitude is the angle of region from equatorial plane. Right? Equatorial plane means the plane which passes through center of our Earth and our equator. Longitude and latitude are complete circles around the Earth. Latitude are complete circles, longitude are semicircles. So this statement is actually wrong. Distance between two latitudes is approximately same. Yes, distance between two latitudes is always approximately same, whether you are in higher latitude or lower latitude. The distance between longitude, that is which varies. 0 degree latitude and 0 degree longitude meet in Gulf of Guinea, which is beside the on the western side of our African continent. So again, this statement is also true. So we see this first one is true, third is true, and fourth is true. 1, 3 and 4. C is the right statement. So with this, we will conclude our first chapter of GC Leong. I hope you enjoyed this video. We will soon start our series in Hindi and we will soon start the NCERT series in which we will use NCERT books and cover each topic. So please stay connected and thanks for watching the video. Do write in the comments your views and if any course correction is required. We are in the learning phase. This is only our second live stream. Do share it with your friends if you like the video. Thanks for watching.